Hello everyone, Lauren Bean here. This is a video for the cow eyeball dissection. So all you're gonna need for this is a scalpel blade, a probe, a pair of scissors. Get a nice clean environment for yourself. It would be handy to have your cow eyeball labeled kind of dissection mat here, provided by your Carolina Distance Learning lab kit. That's handy to have so you know what you're looking at. You will find that my steps are going to be a little different than what's provided by Carolina. That's just because I just like to do it a certain way. And if you were to even, Google cow eyeball dissection videos, you're going to find everybody does it a little bit differently. It doesn't really matter as long as you're looking at all the same features. So you're probably first thinking like, ew, this thing is gross. One reason it looks so gross is because it has a lot of additional connective tissue left intact. So here, as I flip it around, this darker tissue, that's actually muscle that anchor to the eye. All of this white is fat and connective tissue. Then when we're toward the front here, we're actually looking at the eye itself. Almost can see where the pupil would be. But this eyeball in particular is pretty compressed. You can squeeze it a little bit. So here would be the cornea protecting that opening to the eye. It's pretty gross because it's been sitting in preservative, so it's no longer perfectly transparent. You can see this little bit of a clear region here. This would be the pupil, the opening. So just deep to that is going to be the lens. And then you're going to have the iris here. We'll see these features a little better once we open it up. First thing you want to do is take your scissors and clean up all of this excess connective tissue. I want to get down to the optic nerve, and you can be pretty aggressive with this step. It's super hard to cut through, so just gonna kind of do some hacking actually. So just cut, just cutting off muscle and connective tissue right now. Okay, so there is the optic nerve right there. That's what I'm trying to avoid, but I'm trying to clean the area around it so that I have a nice spherical eyeball and I know exactly where that optic nerve is. You can use the scalpel blade if you want to. I prefer not. You're more at risk of cutting things you don't want to, and you're more at risk of cutting yourself. The scissors are pretty straightforward. It's actually my favorite dissection tool. I'm usually just using my hands or the scissors for the most part. So probably as you do this, you're realizing why your eyeball does not fall out. It is anchored by a lot of muscle, a lot of connective tissue. It's held very, very closely in place. All right, I'm gonna say that's good enough. You don't have to get super carried away because you could literally spend like an hour just cleaning the eyeball up. So, it's pretty spherical now. I know where the optic nerve is. Very tough cord-like structure, transmitting all that information from the retina to the brain. Now, the next task is to remove the cornea, and that's this transparent region here. It's an extension of the sclera, this tough white fibrous wall of the eyeball. So I actually do use the scalpel blade for this step just to make a small little nick. See, now I know I'm into the cornea. Fluid is gonna start to come out. And then I use my scissors after that, once I've made a nick into the cornea, and follow that right around. It's also super, super tough. And you don't wanna cut too deep underneath. So I'm just flapping it up to show you that I am just cutting the cornea at this point. So you don't want to like jam your scissors in. You want to keep them fairly flat like this so that you know you're only removing the cornea. So it's pretty cool that cornea transplants are capable, but can you imagine being the eye surgeon removing someone's cornea to put on a new one? Such delicate, crazy work. All right, so there is the cornea. I've snipped it off, And like I said, this is the transparent extension of the sclera, sclera being this really tough fibrous tissue, that wall of the eyeball. Okay, so now what we can see is the iris, right? Very dark in this particular cow eyeball, but you know, in us, we have coloration to the iris, and then deep to it is the lens. That's what that white structure is back there. It's very hard. You can even feel that kind of like this. What's kind of gross, but what I want you to do is now tip your eyeball upside down, and you're actually gonna pop the lens right out. Be careful, be careful with this. It's slippery. You don't want to throw a lens at somebody. So I'm squeezing, want to be able to show you, but not make a disgusting mess. Okay, so you see I'm squeezing, I'm squeezing, I'm squeezing. Pop, you just gave birth to the lens of the eyeball. So let's take a look at this. Pretty crazy. It's like a really, really tough marble almost. So the proteins within the lens really harden once they are in the preservatives. You know, after death, the proteins really start to denature and get super hard. But in real life, you know, it's going to be transparent, it's flexible, it flattens, you know, it gets wide depending upon the vision that is needed. So it can accommodate, it can change shape. Individuals that need glasses, their lens is not really working appropriately. It's not refracting the light correctly. So you just slap another lens in front of it to accommodate for that, okay? The fluid that came out here, anything anterior to the lens, that is called aqueous humor. That is the fluid in the anterior segment of the eye. And beneath or behind the lens at this point, we're gonna find another fluid called vitreous humor. And the consistency is very different. It is more gel-like, and you're clearly gonna understand the difference. So to look at that vitreous humor, you're just gonna go ahead and squeeze your eyeball, position it downward. You're gonna have some jelly-like substance squeeze out. That is all of the vitreous humor found in the posterior segment of our eye. So you can kind of feel it. Again, jelly, very jelly-like, total different consistency than the aqueous humor we find in the anterior segment. The vitreous humor is really good at maintaining that appropriate pressure within the eye, keeping the lens where it needs to be, keeping the sclera, the other layers of the eye, where it needs to be positioned. Okay, so that's that aqueous humor. Now we want to make a cut into the eyeball so we can see the different layers inside. So I'm gonna go ahead and start where the cornea was, and I'm making a nice clean cut around. When I go around, I don't want to cut the optic nerve in half, so you just want to go to one side or the other of that. Just kind of opening it up so you start to see inside a little bit. All right, I'm just going to make it cut all the way through. And it's really going to be however works best for you, but you do want to try to cut it cleanly in half. You got to be a little bit careful here, trying to leave all of the layers intact. Okay. Now that we have a cut into the eyeball, we can see the layers of the eyeball wall really well. So this delicate layer right here is the retina. This is responsible for producing vision. It has the photoreceptors, our rods and cones, and it's a very delicate tissue. So you can even just take your finger and actually scoop out the retina. You'll probably scoop out some vitreous humor with it as well. And that's because that vitreous humor is really good at keeping the retina in its appropriate position. It is very delicate, so it needs that help. It needs that, you know, intra-eyeball pressure basically to keep it in place. On this half that I have here, you can see it's kind of lifted up like that. So very, very delicate. So I'm just kind of scooping that out with my finger. What you're gonna find as you scoop it out is you're gonna find this point of attachment. And this is where
The retina
starts to form the optic nerve. So you can see the nerve right here, right? So it's passing through the eyeball wall. Right where it turns to become the optic nerve, we call that the blind spot. And that's because this region is not capable of taking in an image. The photoreceptors aren't capable of doing anything at that point because the retina is turning and it's forming that different structure. So we call it the blind spot, or another name for that is the optic disc. Now you're probably noticing this really pretty internal color here. So all of the black is representing the choroid layer of the eyeball. And in cows, they have something called tapetum lucidum, this really pretty iridescent color to them. This is found in grazing animals, really any animal that eyeballs are reflective, right? When you're driving at night and you see eyeballs reflecting back at you, that's actually due to this tapetum lucidum found associated with the choroid layer. We do not have this in our eyeball, unfortunately, but it's super pretty, right? It allows them to see a little bit better at night. And you can kind of peel it off if you want to do that. You're peeling off that choroid layer. Choroid layer is highly vascularized, a lot of blood flow coming in, nourishing the retina. So as you tear it off, the next layer deep to that is the sclera, that white, really fibrous, dense wall of the eyeball. Provides a lot of protection, maintains the shape of the eyeball as well. What I've cut in half here is part of the iris, and then internally it makes up part of the ciliary body. So something that we can do to visualize that a little better is actually just kind of cut this front part of the eyeball. Okay, and then flip it over. So you have one half here, right? This is where the lens of the eye would be sitting, part of our iris. Collectively, that whole structure there is the ciliary body. It has suspensory ligaments which hang from there, connect to the lens, and are responsible for changing the shape of the lens depending upon what we're looking at. And then the iris has different muscles inside that change shape as well to either dilate or constrict the eye, right? Depending upon the time of day, is it really bright? Is it dark out? Really regulating the amount of light passing through the eyeball. Okay, so that's what I want to cover for the cow eyeball dissection today. Make sure you work through this activity for yourself, take pictures if you want to, look at the lab diagrams, and utilize your dissection mat provided to you by Carolina Distance Learning Lab Kits.